Hello, everyone, and welcome to the new podcast, AI and You. I'm your host, Vicar Sayeedi. I'm a computer scientist and engineer by training. I spent the first half of my career working in the technology industry and the second half in the pharmaceutical industry, where I continue to work in medical affairs. I'm also the author of several books. My most recent book is about artificial intelligence and is titled The Genome Affair. The Genome Affair is a work of speculative fiction. It examines what the world might be like if some of the more extraordinary capabilities forecast to be realized in AI over the next 20 or 30 years were actually realized today. The book has a particular focus on the impact of AI on world affairs. The Genome Affair is available in ebook format for those who prefer to read on a digital device, but it's also available in a high-quality paperback edition. In my experience, the vast majority of my readers still prefer a high-quality book they can hold in their hand and enjoy the smell of paper. They want to experience the tactile feel of turning pages, the pride of displaying books on their bookshelves, and sometimes even getting their copy of a book signed by the author. I can't blame them since I feel much the same way. My book is available on Amazon, so I hope you'll take the time to read it. And now, on to the podcast. We hear about artificial intelligence quite often in the news these days. Virtually everyone has something to say about this phrase du jour, but there's actually quite a lot of depth to AI, and so I thought it would be valuable to have a podcast to talk about it. You see, AI is much like politics. Many people say they're not that interested, but unfortunately, politics does have a considerable impact on our lives. It seems artificial intelligence is much the same way. If you're here listening, I suspect you're one of the more aware individuals who realizes just how important it is to get a handle on this critically important technology, and you should be commended for this. To say that AI is critically important is a really dramatic understatement. In the coming years and decades, AI can be expected to impact virtually every aspect of our lives, from the economy to the job market and workplace, to government and international relations, world affairs and military conflict. It seems virtually all areas of human endeavor are likely to be impacted. So, given this reality, perhaps it's best we have at least a working understanding of AI and what the future might hold. Let's start by defining what artificial intelligence is. Quite simply, AI is an effort to replicate organic human intelligence in a machine. But what is human intelligence? Perhaps it's best to start with a working definition of human intelligence and the human brain. As you're certainly aware, the human brain is an extraordinarily complex organ. So for the purpose of our podcast, let's work with a simplified definition or model. The brain exists in three major layers. The first layer is deep within our brain and is the most ancient part. It's known as the reptilian brain. The reptilian brain performs all our involuntary regulatory functions, including the regulation of our heart rate, blood pressure, blood sugar levels, etc. It's called the reptilian brain because it has evolved over hundreds of millions of years and performs essentially the same function as it does in the most ancient creatures, the reptiles. The second major layer of our brain is known as the mammalian brain, or the limbic system. This is the portion of our brain that works closely with our endocrine system. The hormones that make us feel afraid, angry, aroused, happy, or sad are managed by our limbic system. The limbic system is also very ancient, but not as ancient as the reptilian brain, and it's something we share with other mammals. Finally, the most recent portion of our brain is the cortex, and it's where we perform our rational thoughts. The cortex is what gives us the ability to be logical and reasonable. The cortex really sets us apart from every other species on the planet. Even though other mammalian species have a cortex, the Homo sapiens is distinct in the sheer density of neurons and the connectivity between these neurons. A typical human brain will have nearly 85 billion neurons and hundreds of billions of connections between these neurons. At rest, the human brain, although only 3 to 5% of our body mass, can consume upwards of 20% of our calories. According to the pioneering primatologist Dr. Jane Goodall, our closest living relatives, the chimpanzees, share nearly 98.5% of our DNA. However, at rest, the chimpanzee brain consumes only about 7% of their calories. Since they don't cook their food, a process that dramatically changes the chemical composition of food, thus making it much more easily digestible by the Homo sapiens' gastrointestinal tract, humans have much more energy available for cognitive activity. Now, to improve our understanding, we need to digress for a short lesson in evolutionary biology. About 70,000 years ago, Homo sapiens, and perhaps as many as 7 or more other distinct species of the genus Homo, were inhabiting the Earth, and none of these species was particularly impactful upon the planet, nor were they particularly high on the food chain. But then something quite dramatic happened. When we examine the archaeological record, we find that after that 70,000-year marker, Homo sapiens suddenly became considerably more impactful on the planet. Everywhere Homo sapiens appeared, the archaeological record confirms a dramatic reduction in the population of megafauna, the larger animals. Homo sapiens had quite suddenly and dramatically risen to the top of the food chain. Scientists theorize that there had been a mutation of some kind or another in the brain of the Homo sapiens. They call this remarkable event the cognitive or rational revolution. From here on out, Homo sapiens have continued to have a dramatic impact on Earth up until the present. Now, with our simplified understanding of the 3 layers of the brain and our understanding of the cognitive revolution providing context, let's return to our topic of artificial intelligence. An important fact to reflect upon here is that AI seeks to replicate only one portion of the human brain, the cortex. AI is trying to replicate the neural network, the astonishing complexity and connectivity between the 85 billion neurons in the human brain. This replication, or artificial intelligence, is only possible because of the staggering computational power available in silicon today and in quantum computing tomorrow, as well as the incomprehensible amounts of digital data so widely available. But we must keep something in mind, something that is never mentioned by even the most brilliant minds in artificial intelligence, cognitive and neuroscience. That is that the human brain functions as it does through a complex interaction between all 3 layers, the reptilian brain, the mammalian brain or limbic system, and the cortex. But as mentioned a minute ago, artificial intelligence research and development focuses exclusively on the replication of the human cortex. Although the achievements in this regard have been astonishing, don't worry, I promise to share these developments with you in due course in these podcasts. It is a cause for concern that AI replicates only one portion of the brain. We must be extremely careful and vigilant with AI because as it increases in complexity and sophistication, we have already crossed the threshold where we are unable to explain or even understand how it has reached its conclusions in a number of different applications. To me, at least, a person who spends most waking moments thinking about the material I'm sharing with you today, this is profoundly disturbing. the AI lacks an emotional, ethical, or moral compass, which in the human is linked to the interaction between the cortex and the limbic system, and therefore AI lacks the ability to be anything more than an incredibly capable neural network. Or does it? Some scientists argue that to think that AI cannot achieve sentience is simply carbon chauvinism. Carbon chauvinism is the belief that unless something is made from the same biological components that we are, it cannot think and feel and cannot be self-aware. But as the evolutionary biologist Richard Dawkins has said, there is no mention in the natural laws ensconced in biology, chemistry, mathematics, or physics that says we must bleed in order to be capable of ethically or morally upright judgment. There is nothing in the natural laws of the universe that says that bleeding is a prerequisite for sentience and self-awareness. When I first started working in AI as a graduate student in the mid-1980s, the artificial intelligence discipline and industry was in a nascent stage. There wasn't much going on that was particularly exciting or innovative, and there wasn't much understanding of how to move forward either. Unfortunately, AI remained in this rut for the better part of the next 2 decades. Leading voices in artificial intelligence, such as Geoffrey Hinton, with their lofty notions of machine learning and deep learning neural networks, were essentially marginalized. But in the mid-2000s, things began to change rapidly. Advances in the understanding of neuroscience, the rapid growth in digital computing power, and the dramatic increase in the availability of data offered a foundation for artificial intelligence to move from the world of algorithms to a world of machine learning. Now, algorithms are nothing more than a series of instructions required to perform a specific task. For example, a recipe is a good example of an algorithm. But if we use algorithms to control and instruct computers, we greatly limit the potential of the machine. Algorithms, even with significant complexity, will greatly limit the capacity of the computer to reach its potential, while simultaneously consuming enormous amounts of time of many extremely smart people who must first write these algorithms and then code them in a language that a machine can either understand directly or can compile into its own machine language. But what if we could get the machine to replicate the way the human brain learns? What if, instead of being responsible for what the machine learns, we assume responsibility for how the machine learns? What if we could model the machine to receive inputs through its senses the way the human does? Homo sapiens collect inputs through their 5 senses: sight, smell, sound, taste, and touch. At present, we are able to teach the machine to learn through sight and sound. We'll talk more about machine learning and deep learning neural networks in the next podcast, and I'll share some incredibly exciting and also some disturbing examples of how artificial intelligence is being used today. Thank you for spending some time with me. I'm trying to follow the TED Talk format, and so I'm keeping these podcasts under 20 minutes. Let me know what you think. I hope you'll find these insights into artificial intelligence helpful. And I do hope you'll read my book as well, The Genome Affair. Until next time then, this has been the AI and You podcast with Vicar Sayeedi.